Hello, ladies and gentlemen. This is Mr. Weideman, and I'm going to do a few review problems for our conic section quiz. I'm going to do circles, and I'm going to do parabolas. Let's start with a circle. I want to find the standard form of, I also do a general form, in points of the diameter. This is kind of one of the more complex ones. So, my first strategy ever when I do any conic section, plot what I know. Now I know that I have been given this and I have been given this. All right, if those are the endpoints of my diameter, then I know by using the midpoint formula, I'm going to get the center. And that's what I've done here. I've used midpoint to find the x-coordinate and y-coordinate of the center. Okay, so that helps a lot. What's the last thing I need to do? I need to find the radius. Probably the easiest thing to do to find the radius is you can use your distance formula, which I don't particularly teach, because the distance formula is simply Pythagorean. If you just absolutely insist on using the distance formula between these 2 points, go ahead, have at it. It's a lot more laborious. Otherwise, I can just realize that I have a simple little right triangle here, and r squared is going to be the hypotenuse. All right, so r squared then is 5. Radius itself is the square root of 5, which is about 2.24, just an approximation. So I come up, what, 2 1/2 units, go over 2 1/4 units, 2 1/4 units, 2 1/4 units, draw my circle. All right, there you go. Now let's do our equation. For a circle, there's our standard form. Plug in our x and y coordinates. Watch the signs. Remember, standard is negative, so x minus a -1 positive. R squared, not r, goes here. There's your standard form, and 90% of the time that's good to go. Might have one question where it says, I want it in general form. First thing you do, FOIL everything out. All right, and then after you FOIL everything out, general form of any equations, set it equal to 0, get all your variable stuff on one side of the equation, 0 on the other side. So we've just got some cleaning up, combining like terms, a little bit of goat herding and stuff like that. And I'm just kind of grouping the x terms together, grouping the y terms together. That's just kind of style points. Kind of move the 5 over and combine it with all these other guys. And this is the setup that we like to see for general format. Other things in general format, usually they just like it completely in descending order, usually with the x variable first. Okay, and a lot of times you'll see general formula written like that. Actually, probably more like this and like this. This is your sloppy general. This is your not sloppy general. Okay, parabolas. I picked this one from your review exercises, number 21. All right, what am I given? I'm given the focus. So I was given this data point, and I was given the directrix. And that's all I was given. What do we do from here? Okay, well, I know, being a parabola, that the vertex is going to lie midway between the focus and the directrix all along the axis of symmetry. So that gives me my setup. I know that I'm going to have a horizontal orientation parabola. All right, and because I know this distance is 2 and this distance is 2, that gives me my values of A. Twice A is going to set up my lengths for here and here for my lattice rectum. Okay, so I got all that stuff. So when I get my vertex, okay, I can see it's centered on the origin. So in my standard equation for a horizontal opens left parabola, this is what my standard equation looks like. Do you have your standard equation for a vertical opens up memorized? If you don't, you need to. Now let's just plug in the values we know. Vertex, that means HK and 0. Okay, be a little bit careful here. -4 times A. There's our standard format. Y squared is equal to -8x, all cleaned up. What if I want general? Okay, just put everything on the other side of the equation, set equal to 0. And that's all there is to that one. Okay. All right, so in the next video, I am going to do ellipses and parabolas. Ellipses and hyperbolas. Ellipses and hyperbolas are very, very close relatives.